In this problem, water is being poured at a rate of 12 cubic feet per minute into a conical reservoir, which is 15 feet deep and has a base radius of 9 feet. And there are 3 parts to this. In part A, it says, how long will it take to fill the empty reservoir? How fast is the water level rising when the water is 2 feet deep? And how fast is the radius increasing when the water is 2 feet deep? Now, we first need to set up a diagram. We can do this by drawing a cone-like shape to represent the conical reservoir. And, yep. Now we must label what is given to us, especially the radius, which is 9 feet, and the height, which is given as 15 feet. It's cut off, but it's there. Now, we know the formula is V equals to 1/3 pi r squared h, and this formula inhibits all our variables, so it's the easiest one to use. And also, the derivative of our volume is 12, which is also given. So let's write those down. Our h of 15 is also given, but we don't know the derivative of the height, so that remains unknown. Now, in order to make one variable out of r and h, we need to set a proportion of r over h, which equals 9 over 15, and simplified 3 over 5. Now, r equals to 3/5 h, or 3 over 5 times h. And we can plug this in back into our volume formula for r. So v, and then we can simplify it further from 1/3 pi to times 3 over 5 h to the power of 2 times h. And let's simplify it all the way so it makes it easier to find the derivative. And you'll see after a little bit of simplification, our answer is v equals to 9 over 75 pi h to the third, and we can take the derivative of that, and it makes 27 pi over 75 h to the second dh over dt, which will be written. So again, dv over dt, the same thing as the one above. Simplify 27 over 75, which is 9 over 25 pi h to the second dh over dt, since we're taking the derivative of h and involving time. Now, using this equation, this derived volume equation that's simplified, we can plug in our derivative of the volume into the equation and our h, and find our dh over dt. So, equals 9 over 25 pi times 15 squared times dh over dt. And now we can simplify and isolate dh over dt, which gives us 0.472 feet per minute. In order to cancel the feet, we must use that number divided by 15 feet. Feet over feet cancels, and that is left with 0.0315 minutes. Sorry, 0.00315 minutes. And that is your answer. So in part B, it asks, how fast is the water level rising when the water is 2 feet deep? Now, what we can do is find dH over dt, as that's the rate we're trying to find, and draw a diagram, which can be represented by a downwards right triangle. Then we have to shade the part that's already filled with 2 feet of water and label that 2 feet. Then label the radius of 9 feet and the height of 15 feet. Now, since we already found the derivative of volume equation and computed it for the 15 feet of height, we can do the same thing with 2 feet, since we're both finding dH over dt. So let's use the equation where 12 equals 9 pi over 25 times 2 squared times dH over dt. And after a little bit of algebra, we find that dH over dt equals to 2.65 feet per minute, which is the rate of the increasing height. So the final part C asks, how fast is the radius increasing when the water is 2 feet deep? So when it asks how fast the radius increasing, we know that we have to find the rate. And we can do that by finding the derivative, which is dr over dt. So let us write what we need to find. Dr over dt equals to, well, we don't know yet. And we know that from our proportion from part A that R equals to 3/5 h. And the reason we use that is to isolate the variable in terms of h. Since we're trying to find the rate of the radius r, we simply have to take the reciprocal, which is h equals to 5/3, 5 over 3 times r. And if you see, a less complicated approach into finding dr over dt is simply taking the derivative of h equals to 5 over 3 times r. And that is what we can do. So, dH over dt equals to 5/3 dr over dt, as the derivative is relative to time, as rate is the number of feet per minute. So, yeah. So as you can see, the equation above is simply the derivative of the equation. The equation on the bottom is the derivative of the equation above. And, well, 2.65 is dH over dt, so let's write that. Plug it in, equals to 5 over 3r, dr over dt. Then we simply isolate dr over dt and solve, which is 1.59 feet per minute, which is the increasing rate of the radius when the water is 2 feet deep. Okay, and that's it.